Hello and welcome to Tensile Ground Coffee, a few minutes on ground engineering to enjoy while having your coffee. Well, we've come to Belfast, Northern Ireland, and exciting things are happening in Belfast. A lot of new developments over the past 10 years, not least this flagship project, the Grand Central Station in Belfast. So we're lucky enough to come here during construction. When it opens in around about autumn 2024, it's going to be an integrated transport hub with a bus and rail station handling about 14 million passenger journeys per year. And this is the main rail station. You see the big overall roof over there and the 4 island platforms here, creating 8 tracks for the terminus. If you turn around, Brian, you'll be able to see the tracks heading out and under the new bridge out towards the various lines out of Belfast. So an impressive enough station on its own, but when you think that all this has been built on the notoriously challenging Belfast Sleech. Now, Belfast Sleech around here is up to an 8-meter thickness of estuarine alluvium with the consistency of toothpaste. Undrained shear strength can be as low as 5 kilopascals, so very challenging ground conditions, and that would explain why most of the buildings in Belfast city centre are supported on piled foundations. But that wasn't an option for these tracks here, so it needed an innovative solution and an innovative design method. So I'm very excited to be here because this is the first application of our new performance-based design method for railway formations. So we use 3-dimensional finite element analysis with advanced hardening plasticity models to predict very small permanent deformations in the subballast and the formation layers in response to wheel loads right at the track surface. Then we use deformation accumulation functions to predict how those deformations under the first loading will accumulate during successive repetitions of that loading throughout the whole design life. Furthermore, we can incorporate the benefit of mechanical stabilization in the subballast layer. So under these tracks here, and as we head out under the new bridge, underneath the ballast, the subballast contains tensile geogrid. That mechanically stabilizes the subballast, improves the subballast, and we get far better performance out of it, which means we need less of it, so thinner subballast layers. So less aggregate is needed, less excavation of the existing ground, faster construction times, lower embedded carbon. It's a win-win. So I'm excited about the new design method and excited about the application of tensile geogrids here as well. And because the new design method can predict that performance throughout the design life, it's been designed to minimize maintenance needs throughout the design life of these railway tracks when they enter service later this year. So a big thanks to Farrans and Sasir, the joint venture, for allowing us onto their construction site. It's been a real treat to see this station before it opens to the public. So that's all for this episode of Tensile Ground Coffee. Thanks for watching and see you next time.